Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides even more practice using StatCrunch to conduct hypothesis testing and construct confidence interval estimates for two paired population mean values. Let's get started. So for this mini lecture, we're going to be looking at an example involving the use of hypnotism for pain reduction. So the tabulated data that you see there at the bottom is reporting pain scale measurements that were recorded before and after each of 8 randomly selected people were hypnotized. So the higher the measurement, the higher the level of pain. So we've got the same standard questions that we're looking at before. And in this mini lecture, I'm actually going to be letting you take the wheel more. So there's a data set that's the same data set that you see there at the bottom of your screen. It's there in our StatCrunch group. So go into StatCrunch and open up that hypnotism file, and you can get the same data here so that you can actually get some practice in actually performing the steps for the procedure for hypothesis testing and constructing confidence interval estimates. So first we're asked about our hypotheses. So go ahead, stop the video here, form your hypotheses, and then come back and we'll see how well you did with that. Okay, let's see how well you did with that. So first we're going to think about the claim that's being made. Okay, the claim that's being made is that hypnotism is effective in reducing pain. So the one measurement, the before measurement, should be greater than the after measurement. The before measurement was mentioned first, so it has subscript 1. The after measurement then has subscript 2. So 1 is going to be greater than 2, and therefore mu sub d is going to be greater than 0. The null hypothesis, by always definition, a statement of equality. So mu sub d equals 0. And then our alternative hypothesis typically comes from the claim. There's no semblance of equality with this claim, so we can just adopt it as our alternative hypothesis. So this is what you should have gotten for your hypotheses. Note that inequality sign there on the alternative hypothesis means that we have a one-tailed test on the right. What is the test statistic? Well, you've got the data there. So go ahead and put that into StatCrunch, see if you can calculate the test statistic, and then come back here to the video and we'll see how well you did. Okay, let's see how you did with this. So hopefully you put the data there. You can either type it in by hand or, what I recommend, just go to our group in StatCrunch and load that data file in. And then once you got the data into StatCrunch, go to Stat, T-Stats Paired. And then here in your options window, make sure you list the before column as the first sample, the after column as the second sample. That value there that you see there for your inequality sign, make sure you got that to match up. And then go ahead and hit compute. And this is the results window. You should see the test statistic. You read that right off the results window. That's second to last value that you see there. The p-value, of course, right next door to the test statistic, the last value listed in your data table. So this is what you should see for your results. Will you reject the null hypothesis or fail to reject the null hypothesis? Again, pause the video and then make your decision and come back and we'll see how well you did. Okay, let's see how well you did with this. So if we're outside the critical region, which is the region of rejection, we fail to reject. If we're inside, we reject. So if we were to look at our critical value, our region of rejection, here's what we get. So our alpha level, 5%, a one-tailed test on the right. So we're looking at the right tail of our distribution. Here's our alpha level. That's the area of the right tail in our distribution. And the boundary for that region is going to be our critical value. So 1.89 is our critical value. And of course, we've got 7 degrees of freedom because we've got a sample size of 8. So to evaluate whether we're inside or outside our region of rejection, we could go back to our results window, look at the p-value. If we look at the p-value, we're comparing it with the area And so 0.0095 is going to fit nicely inside 0.05. Therefore, we're inside the region of rejection, and we reject the null hypothesis. Alternatively, if we use the test statistic, 3.03 is going to be, somewhere right around in here, because the boundary region here is 1.89. So we're going to be inside that tail, inside the region of rejection. Therefore, we reject the null hypothesis. What do you conclude from the hypothesis test? Well, again, pause the video. Should be able to use that pattern to come up with the right answer. Then come on back to the video and we'll see what you did. So here we should have the actual answer we're looking for is answer option C. Notice where each part of the right answer comes from. Okay, we rejected the null hypothesis, therefore there is sufficient evidence. We have a one-tailed test, therefore we're going to support the claim, and the rest of the statement is just a rehash of the claim itself. What is the appropriate confidence interval? Well, you've got StatCrunch. Go ahead and figure that out after you pause the video, then come back to the video and we'll see what you did with that. Okay, let's see how you did with that. So, if you go back to your options window there in StatCrunch and then just switch that radio button down to confidence level, you're all set as soon as you put in the confidence level. And the appropriate confidence level here is going to be 1 minus 2 alpha, because we have a match between our claim and our alternative hypothesis. So because of that, 2 alpha is going to be 2 times the 5%, which is 10%. 1 minus 10% is then 90%. So 90% is going to go here in our field for confidence level. Once we press compute, out comes our results and the lower and upper limits for a confidence interval right there at the end of the table. So this is what you should have for your confidence interval. What do you conclude from comparing these results? Well, go ahead, pause the video, make your conclusion, then come back and we'll see what you did with that. Okay, let's see how you did with this. So the key thing you want to look at when looking at your results to make a conclusion is 0 inside or outside the confidence interval? Here 0 is outside the confidence interval. In fact, 0 is on the left side of our confidence interval. That means that all the values in the confidence interval are going to be greater than 0. And that means that mu1 is always going to be greater than mu2. So if you remember the order in which you put things in, before is sample 1, after is sample 2, so that means that before is always going to be greater than after. And that means you're always going to see a reduction in those pain measurements. Therefore, it suggests hypnotism is going to be effective in reducing the pain. So either way you look at it, okay, this is the same conclusion that we reach with the hypothesis test. Okay, there's sufficient evidence to accept the claim that hypnotism is effective in reducing pain. So either way you look at it, you're going to come out the same way because we're dealing with mean values here. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.